Hi everyone. Here I have another example in which we want to reduce the block diagram, is given set of block diagram to a single transfer function. So as you can see here, we have G1, G2, G3, H1, H2, H3 connected to each other in a given way, in a given manner. So before starting, I would like to remind you some of the rules which we have in reducing the block diagrams. So sometimes we need to move a given block before the summing point. So for example, if we have this case, which we have a summing point for which we have input signals R and X, I would call them. And afterwards we have a block diagram, a transfer function, which is called G1. And as the output of this system, we have CS. So in this case, we can move this block G1 before the summing point. This would help us in reducing the overall block diagram sometimes. The way to do it is in this way. So we will have R, then the block diagram G1, summation point, and then we will have G1 again here with X as the input, and the output will be equal to CS. So for both cases, we can see that CS is equal to G1 times R plus X. And in this case as well, we have C is equal to R times G1 plus X times G1. So both of these are equivalent to each other. Same thing happens when we want to move the block after the summation point. Here we have one example. So I have G1 here with R as the input of the block. And then we have a summation point. So the sign doesn't matter here, let's say. And afterwards, S is one of the is an R output input, and then C is the output. So this is also equivalent to the case in which G1 has moved to this point after the summation point. However, in this case, we will have this situation. So R is the input. We have the summation point. Then G1 will appear here, and C will be the output. On the other hand, so we had positive signs here. For XS, since in the previous case, G1 was not in the path from X to C, as you can see here. Now we need, and now G1 appears here before G1, we need to cancel its effect. The way to do it is to add this 1 over G1 here. So from here, we can see that C is equal to G1 times R plus 1 over G1, which means that C is equal to G1R plus X, which is something that we have here. Yes, C is equal to R times G1 plus X. So these two are equivalent to each other. Another case in which we need to move the blocks is when we want to move the blocks to the left or to the right of a branch point. And I will show you here a very simple example. So for example, here we have one signal R, and then we have some branch here. We have branch point, which gives us here a signal G1 times R. Here we will have R itself, and here we will have R again. So now if you want to move this G1 to this point before the branch point, what we will get will be like this. So again R, G1, then this is our summation point. There will be nothing here, so we will have G1R. In the other ones, we will have 1 over G1, 1 over G1. And so accordingly here we will have R and R. So you can see that these are equivalent to each other. And another case would be when we have the block before the summation point, before the branch, point, and we want to move it to the right side of the branch point. In this case, what we need to do is only to take that block and move it in front of all the branches. So we have G1, G2, G1, G1, G1. So this is the way in which the block will move from one side to the other side of the branch point or the summation point, as you already had seen here. So now we can go forward and start to reduce or simplify our function block diagrams which are provided here. We need to reduce it to a single transfer function. So okay, I think I will move this to the lower part in order to have access to it easily. Okay, so as the first step, let's focus here. So what do you see here? We have a summation point in which there are 3 signals coming to it, 2 with the positive sign and another one with the negative sign. What we can do here is quite simple. So we have this situation, plus, plus, and minus. This can be replaced with 2 summations in which we have the original V3 and V4 signals, V4, V3, with the plus signs, and from below we have the V8 signal. And if you look here, then we will have a simple feedback loop here. So I can draw it here maybe. We have G3 and H3 here, which can be easily reduced to a single transfer function. You already know it is G3 divided by 1 plus G3 H3. And here we have the plus sign, here we have the negative feedback. So this can be used in order to replace this part of the block diagram. Now let's see what is left here. So we can, focusing here, we can see that this G2 is located between these 2 points. So here we have a branch point and here we have another branch point. To make things simpler, what we can do is that we can take this branch point and move it after the G2, or the other way, we can move the G2 before the branch point. Let's see how can we do it. So let's focus here on this part. V3 is here, and then we have G2, a branch point, another branch point. Here we have V4, H2, and a summation point. And there is another summation point here. So V4, v3 both plus with plus signs, and afterwards we have this. I will call this. I will call this T1 for now. So we will have T1 here and CS as the output. So what I can do here is that I will move this this G2 before this branch point. How can I do it? It's somehow straightforward. I will redraw it with plus and minus signs here. We have V3, then G2 will appear here. We will have V4, and if I have the branch point here, now I need to have 1 over G2. To have V3 here. And H2 is already located in the feedback path. So as you can see here, V3 is the equal to the output of the summation point, and here we have it V3 is equal to 1 over G2 times G2 times the output of the summation point. So these are equivalent to each other. On the other hand, V4 is equal to G2 times V3. V4 is equal to G2 times V3. So these two are equivalent to each other. We have T1 here. T1 yes. On the other hand, what I can do right now is that I will exchange the location of these two branch points because they are identical to each other. So this will be equivalent to, so I don't need that here. We have plus and minus H2 G2 as a feedback loop. And then afterwards here we have the summation point in which we have two passes, 1 over G2 and then we have here. Now what we have here is that these two can be combined with each other and these two can be combined with each other. These are parallel to each other, 1 over G2 and here we have 1. So the resulting transfer function will be 1 over G2 plus 1. And here for these two, the resulting transfer function will be equal to G2 over 1 plus G2 H2. Again, pay attention to the sign here. And these two function blocks or transfer functions are series with each other. So this one can be also simplified to this case 1 over G2 plus 1 is equal to 1 plus G2 over G2, which will be used. So now let's have a look here. So we have moved this point to the right side of the G2, and as a result we have obtained this transfer function here, this transfer function here. But we need to keep in mind that we are still using the V4 signal here through H1. So we cannot combine them, otherwise we will miss the signal. Okay. So now let me maybe make it more clear here. Again, I will move this image here in order to focus on it. So what we have right now here is this. We have R summation point G1 Then instead of all this, we have, maybe I can call them with some name. This one can be considered as T3 and this one as T2. Here I have T3, then T2, and then T1 and CS. And right from here, which is the output of T3, we will have this pass, which is H1 with a negative feedback. Okay, now I think everything is quite simple. These two are in series with each other, and the results will be in a feedback loop with H1. So it's quite now straightforward to simplify it. What we have here is for these two we will have G1 T3. Therefore, for the feedback loop we will have G1 T3 divided by 1 plus G1 T3 H1, which is in series with T2 and T1. So this will be indeed what we get as the overall transfer function T2 and T1 and CS. As a result, C over R, which is our transfer function, overall transfer function, will be equal to G1 T3 over 1 plus G1 T3 H1 times T2 times T1. And now the only thing that we need to do is to replace this T1, T2, and T3 with the corresponding expressions. So let's have a look. Here we have, where is our T1? T1 is here. So G3 over 1 plus G3H3. I will rewrite it here. T1 is equal to G3 over 1 plus G3H3. T2 is equal to 1 plus G2 over G2. 1 plus G2 over G2. And T3 is here. G2 over 1 plus G2H2. G2 over 1 plus G2H2. Now, yeah, we just need to replace them. T is equal to G1 T3 will give us G1 G2 over 1 plus G2 H2 divided by 1 plus G1 T3 H1, which gives us G1 G2 H1 over 1 plus G1 1 plus G2 H2, the same as what we have here. This is G2. Okay, and then we have T2, 1 plus G2 over G2 times T1, which is G3 divided by 1 plus G3 H2. And if we simplify it, we will get 1 plus G2 H2 plus G1 G2 H1 G1 G2 times 1 plus G2 over G2 times G3 over 1 plus G3 H2. And simplifying it further, we will get 1 plus G2 H2 plus G1 G2 H1 times 1 plus G3 H3 at the denominator and G1 times 1 plus G2 times G3 at the numerator. So here pay attention that the G2 in the denominator and G2 in the numerator are cancelled with each other. This might not be the case all the time, but here for this simple example, I assume that it is possible to cancel them with each other. Okay, so this is the resulting transfer function that we can get by reducing the whole block diagrams that we had for this given example. Thank you again for watching. I hope you had found this helpful in helping you to reduce the block diagrams and obtain a single transfer function for the system. Thanks a lot for watching again, and see you next time.